Hi guys, and welcome back. Yes, we are now kickstarting, um, uh, you know, um, the talk on general solutions in terms of routine, uh, 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 expression like routine calculations and stuff like that. However, this is, I said in the previous videos that most of the stuff is routine, and that is true. Everything that I've discussed is routine, but in general solutions, you're going to now start to have complex procedures. Okay, you're going to now start to solve some complex procedures, and so this is where you actually need to get your head on this whole thing, and make sure that you don't fall behind, you don't misunderstand anything, because misunderstanding can really be deadly. Now, guys, if you remember, we spoke about the CAST rule, all students take care, okay? And it is very important to know our CAST rule diagram when we deal with general solutions. So I'm going to do a few examples, but in doing those examples, I'll be referring to the CAST rule so that you see exactly why I do what I will be doing, okay? In the next few examples, I will not really draw the CAST diagram. I will just be referring to it, reminding you, okay? So remember, theta was our angle, and I said in this quadrant, we are dealing with the reduction 90 degrees minus theta, okay? And I also said in this same diagram, we are dealing with the reduction 360 plus theta. In this diagram, we are dealing with a quadrant. Sorry, I don't know why I kept saying diagram. In this quadrant, we are dealing with the reduction 90 plus theta and the reduction 180 minus theta. Here, we are dealing with the reduction 180 plus theta and the reduction 270 minus theta. This side we will have 270 plus theta, or 360 minus theta. Now, sine is positive in the first and the second quadrant. Cosine is positive in the first and the fourth quadrant. And the tangent is positive in the first and third quadrant. Okay, something is very special about the tangent, and I will talk about that as I go through these examples. So as I said, we have seen in the previous video when I used graphs, and it is in the same sense that I will also say this, that you can see the issue is around the sign of the ratio here. Mainly when we deal with general solutions, you can see for sign. So when you are given an equation, you need to check, okay, what is the sign, okay, of this thing that I am being given, okay? So guys, in general, this is what you are going to have. You're gonna get I think about five types of equations, and I'm going to start obviously in this case with the type 1 equation that you're gonna get, meaning a level 1 question, very basic one, should get this one correct. Okay, you should not miss this one. So you're gonna get something like a single trig ratio sine theta is equal to, let's say for argument's sake, 1/2, okay? Now, another way they ask this, they can say to you, well, 2 cos alpha is equal to -1. Or they might even make it even much trickier and say 3 tan x is equal, not is equal to, 3 tan x minus 1 is equal to 0. Guys, these things might appear differently, but they are essentially one and the same equation. This one, we don't have to do much work. Here, we've got to do a little bit of work, meaning tidy up and see if we can get it in that form. This is the standard form of a trig equation. I told you, I mentioned it also in the grade 10 video when I was introducing equations. So of course, that's just to remind you at your level of grade 11. So we're quickly going to solve all this stuff. We're going to find the general solution for each equation, and then, yes, get around that. So let us see. First of all, sine theta equals to half. 1 or 1 over 2. I said that one is easy. So the first question you ask yourself is, okay, what is my reference angle? In other words, what is this theta? What angle makes this or gives the ratio to be 1 over 2? If you remember your special angles, that angle is 30 degrees. If you do not remember, then you should remember how we solved these equations in grade 10 when we had that we'll take arc sine on both sides, okay? And so, and you know, to access this function in your calculator, you've got to press shift, then the button sign. Then we get theta is equal to 30 degrees. Now, this is not your solution. This is the first step to the general solution. What is this theta? This theta, or this 30 degrees, it is this angle here that we are talking about. Now, the second thing that we are going to look at is the sign. Okay, what is the sign here? The sign is positive. Okay, that's a positive 1 over 2. Okay, now that sign tells us, okay, go to the quadrants in which this thing is positive. What are those quadrants? We know it is quadrant 1 and 2. Now, what is happening in quadrant 1 and 2? And by the way, here we are not going to use 270 reduction or 90 reduction. It's clearly or purely 180, okay? That's it. That's it. That's it. Nothing else. So we look here. What is happening here? There we already have theta in its standard form. So that's cool. So that means therefore our solution is going to be the following. Theta is 30 degrees plus, now I'm going to say K times 360, where K is an element of what? Z, where Z, I'm sure you know the symbol Z means integers, all the negative and positive numbers, including 0, okay? So now, this is my first general solution. Why do I have this? Remember in the graphs, I showed you that there are actually infinitely many solutions, meaning there are infinitely many values of theta for which we will get the ratio 1 over 2. So this is generalization to say to find other solutions. We look at the periodicity of the sine graph. You saw, or even if you don't look at the periodicity of the sine graph, what is the biggest angle here in our Cartesian plane? It's 360. Of course, we can go over a revolution and make many, many rounds, but we saw that it is just going to be what? A repetition. So we are doing this to acknowledge that there are other solutions. So hence the word general, to say it is not specific to say this is the only solution, but there are other solutions. Now, the second thing that the second step that we're gonna take is theta is equal to, now, which other quadrant is sign positive? We said is the second quadrant. Now, what kind of reduction do we use in that second quadrant? That that can be quite confusing. I do not want to confuse you at any point in this case, okay? Therefore, what I am going to do right now is that I'm going to say, okay, sign is positive in the second quadrant, and therefore what I'm going to do, I'm going to observe the rule of the second quadrant. For me to get to that, I need to say 180 degrees minus, what is the value of theta? 30, okay, plus I still have K 360, and it's important, guys, you're really important to always mention that K is an integer, and this is what? 150 plus K times 360, and K is an element of integers, or it's an integer. Okay, so guys, that is very crucial. Unfortunately, like, I don't know how to emphasize crucial, but it is critical. Okay, so we cannot really run away from it. So yes, that is my second solution. So in this respect, I have essentially found the general solution for this thing. In other words, when you try, if you want to find other angles, currently I found what? I have found 30 for you. I have found 150 for you. If you want to find other angles, go on. Substitute there as -1, substitute there 1, and see what other angles will give the ratio 1/2. So that's about it. I said in this second one here, they want us to do a bit of work. So we will go ahead and do that bit of work. We have 2 cos alpha is -1. So we're going to divide by 2 both sides. Then we have -1/2. First things first, before we even consider this negative sign, we look at our reference angle. What is the reference angle? It is, you will agree with me, if you take the shift and all that, alpha here is 60 degrees, okay? Now, we check the sign. The sign tells us, okay, which quadrants is cos negative? It is quadrant 2, this quadrant here, and quadrant 3, that quadrant there. Therefore, my solution will be as follows. Alpha should be 60, not just 60 actually. What is happening in the second quadrant? In the second quadrant, you can see there, I have got actually 180. Can you see that? Minus 60, you see? So I'm going to go ahead here and say 180 minus 60 degrees plus k dot 360, k element of blah, blah, blah. I don't have space. You can go ahead and write that. So this leaves me with 120 k 360 k element of z, the z. And so that is my first solution. Or if you want more, alpha, what other quadrant now is 180 plus. What is happening? 180 plus. So I'm going to say 180 plus 60. That maybe let me start by writing it down. Okay, and then k dot 360 again. K is that, and this is, I think, 240 plus k 360 k element of z. And so that, guys, leaves me with the general solution. So I've got 2 stuff here that can guide me. I will get into the other nitty-gritties where they ask you now to find the specific solution. In other words, they will say find all the angle, all the values of theta or the values of x that fall within this interval, which will give you this ratio of which this equation is true. Okay, guys, why don't you go ahead actually and try this one instead of me doing it now. 3 tan x minus 1 equals to 10. Put this thing in standard form, solve for alpha, and then, yeah, find the general solutions. I'll stop here, and in the next video, we will look into the second type of equation that you can get around these things. I said there's about 5 of them, so you can expect 5 videos in this series, okay? Make sure you have a look at each and every one of them, but the reasoning is essentially the same. It does not really change, okay? Till then, I'll catch you guys later.